Hello friends, my name is Arun Kishore Voleti and welcome to my channel Learn Deep. We are currently in Python playlist. In my previous video, we have discussed about bubble sort algorithm. In this video, let us try to focus on one of the simplest sorting algorithms, that is selection sort algorithm. So without wasting any time, let's get started. So let us take an example list with 10 elements 6, 4, 3, 2, 1, 1, 2, 3, 4 and 5 in the indexes I is equals to 0 to 9. So the selection sort algorithm, the basic idea is we are going to check all the elements in the array and we are going to find the smallest element and we are going to swap the smallest element with element at index I. So let us assume that I is equal to 0 here and now check this entire array to find the smallest element present in the array. So first check with 4 whether 4 is less than 6 or not. Yes, 4 is less than 6. So now the smallest index is 1. Again check whether the other elements are less than the element which is present in the smallest index or not. So 3 is also smaller than 4. So now the smallest index will be 2. Again 2 is smaller than 3. The smallest index will be 3 now. Again 1 is also smaller than 2. The smallest index will be 4 now. Now after this one, every element is greater than or equal to 1. So after this entire verification, I am going to have my smallest index in 4. So the smallest element present in this entire array is 1. So now what I have to do is I have to swap this 1 with this 6, which implies I am going to swap the element which is present in the smallest index with the element which is present at ith index. So after swapping, my list will look like something like this: 1, 4, 3, 2, 6, 1, 2, 3, 4 and 5. Now this part of the array has become sorted. Now in the second pass, what we are going to do is we are going to take the outcome which we have obtained in the first pass and we are going to verify from ith index to the remaining elements. Again we are going to consider the element which is present in the ith index to be the smallest element and we are going to verify each and every element after this ith index and we are going to find whether there is any other element exists which is smaller than this element at index I. As 3 is smaller than 4, now our small index will be 2. Again 2 is smaller than 3, so now our smaller index will become 3. Now 6 is smaller than 2, no, it's not possible, so the small index will remain 3 as it is. Now we are going to check 1 with this 2, as 1 is smaller than 2, now my small index will become 5. So after 1, each and every element is greater than 1, so after this pass what we are going to get is the smallest index is 5. Now the element which is present in this small index is 1, which is considered as the smallest element in this subarray. Now what we are going to do is we are going to swap this 1 with this 4. So our list will be something like this: 2, 6, 4, 2, 3, 4 and 5. Now this part of the list has become sorted. Again we are going to start with I is equal to 2 here. Now we are going to check all the elements present in this list. Now the smallest element is 3 here. And we are going to check this 3 with this 2 whether it is smaller or not. Yes, 2 is smaller than 3 and obviously we can say the remaining elements are greater than 2. So now we are going to swap this 3 with this 2. So after swapping, our array will be something like this: 2, 3, 6, 4, 2, 3, 4 and 5. Now if you observe, each and every pass we are going to get sorted elements from the front. If you consider bubble sort algorithm, we are increasing the length of sorted elements from the back side. Like we are going to push the desired element to the last place and so on. After pushing, at the end of the total passes we are going to get the sorted array. So this is something which is seeming to be looking like reverse of that bubble sort array. Like from the front side it's going to increase the length of the sorted elements. So now what we are going to do is we are going to take this sub array and we are going to find the smallest element which is 2 here. The same logic, we are going to check each and every element with this small index element and we are going to swap these 2 elements. So after swapping, what we will get: 1, 1, 2, 2, 6, 4, 3, 3, 4 and 5. So if you observe, this part of the array will be completely sorted. And now again what we are going to do is we are going to take this part of the array and we are going to check which element is the smallest element. And we found that 3 is the smallest element. Now replace the 3 with the 6. What we will get? 1, 1, 2, 2, 3, 4, 6, 3, 4 and 5. And this part of the array is completely sorted. Now again take this subarray and check for the smallest element. Here the smallest element is 3 and the current element at index I is 4. Swapping these two elements will result in the array like this: 2, 2, 3, 3, 6, 4, 4 and 5. And this part of the array is now completely sorted. Again for this last 4 elements, check for the smallest element, and the smallest element is 4 here. So replace this 4 with this 6, we will get 1, 1, 2, 2, 3, 3, 4, 6, 4 and 5. Now this part has been sorted. And for the last 3 elements, check the smallest element, and the smallest element is 4 again. So let's swap this 4 and 6. We will have 1, 1, 2, 2, 3, 3, 4, 4, 6 and 5. And finally, we are going to check the last 2 elements present in the list. And the smallest element is 5 here. So we are going to swap these 2 elements and we are going to get a completely sorted array. 3, 3, 4, 4, 5 and 6. So in this way we are going to sort the complete array. So by the end of 9th pass, what we are going to have is a completely sorted array. So if you have n elements, you need to take n minus 1 passes in order to sort the array completely. So what is the basic idea behind this selection sort? We are going to select the smallest element in the array and we are going to replace it with the element present in the ith index. Every time you are going to select the smallest element and going to replace with the element at ith index. Smallest element and ith index. So this is the basic logic behind selection sort algorithm. So let us try to write a program to implement this selection sort. So let us take list is equals to 6, 1, 2, 3, 4, 1, 2, 3, 4 and 5. Now what we have to do, we need to take a loop to check all the elements. So for I in range of length of list minus 1. So for n elements we need to take only n minus 1 passes. So after taking this, what are we supposed to do? We need to find the smallest element. As we have done earlier, we need to take small index and assign the small index with I. Now let us write another for loop for j in a range of I plus 1 to the length of the list. So what are we going to do is, we are going to assign the smallest index with I. Initially we are considering this element to be the smallest element. Now what are we going to do is, we are going to check from I plus 1th element, that is from 4 to the end of the list, and we are going to find whether there exists any element which is smaller than our assumed smallest element or not. So what are we going to do? We are going to check if is there any element exist which is smaller than our assumed element or not. Is there any list of j which is smaller than our list of small index, which is the assumed one. If any element is found, then what are we going to do is, we are going to replace the small index with j. That's what we are doing here. Here j will starts with I plus 1, which is 1, and we are going to check each and every element. Every time if you found a smaller element, then you are going to replace the small index with value of j. So that's what you are doing here. So after this complete swapping, what are we going to have is, we are going to have the smallest elements index in Si. Now what are we supposed to do? We are just supposed to swap the element at ith index and the element at smallest index. So list of small index comma list of I. So in this way we can achieve selection sort outcome. So just print our list. So if you run this, you can see a completely sorted list 1 1 2 2 3 4 4 5 6. So what is happening here? We are going to take I as the smallest index, and we are going to run a loop from I plus 1 to the end of the list, and we are going to check is there any other element present in the list which is smaller than the smallest indexed element or not. If any such element exists, then simply replace the smallest index with the new index which we found. Finally, by the end of this loop, we are going to have the smallest elements index in Si. Now just replace the element which is present in the index Si with the element present in the index I. So after completely replacing each and every time, the final pass will result in a completely sorted list, which you have seen in this last pass. So let us just quickly summarize what we have done. We have taken a list and we have assumed that the smallest element is in index I. Now from index I plus 1, we have ran a loop and we have verified whether is there any other element smaller than the element at index I or not. If any such element exists, then quickly replace the smaller index with the newly found index. So by the end of this loop, we are going to have the smallest elements index in Si, and we are going to replace the element which is present in the Si with element present in I. By repeatedly doing this step again and again, we are going to get a completely sorted array. So this is the logic and implementation of selection sort algorithm. Hope you understand this logic. So I'm going to give a task to you, which is I have used another loop here. But now we are in Python. In order to find the minimum element, we have a function called min. By using this min function also, we can find the minimum element present in an array. So the task for you is to implement a selection sort without writing this second loop. You are not supposed to write this second loop, but then you have to implement the selection sort algorithm. This is an assignment, and if you got the answer, post it as a comment. I'll show the answer in next video. So that's all for this video. Meet you in my next video.